All right, we're back for the second half of the 7.5 notes, and again we're looking at parts of similar triangles. So if we jump in, this first one, we've got a new feature. Now, we're going to talk about these features in a little bit more detail later in the semester, but what I want you to notice is that this line goes from a vertex to the midpoint of the opposite side. So we're going to call that feature, it's going to be called a median. All right, so median goes from the vertex to the midpoint of the opposite side. All right, and notice both of these, based on the markings, all right, we've got medians. So this theorem is going to say if two triangles are similar, then the measures of corresponding medians, all right, are proportional to the measures of corresponding sides. All right, so when we look at this, it just allows us to set up another proportion. So if I go over to the right, we've got an example here. It says triangle ABC, so that goes up and over the top, and EFG up and over the top, so those are oriented in the same way. All right, it tells us that BD and FH are medians. So that's going to allow me to rewrite this so these bottom halves, so we know the two pieces are congruent. All right, then it goes on and it says that BD is 6. It tells us AD is 4. All right, which I know that other side's going to be 4, and then the total length of the bottom is going to be 8. It tells us that FH is 2x minus 1. And it tells us that EG, so the full bottom here, is x plus 1. And it wants us to find EH. So the first thing we're going to have to do is we're going to have to find the x value. All right, so we're going to go ahead and set up a proportion. So I've got 6 over 2x minus 1, all right, median over median, equals 8, the full length of the bottom, over x plus 1, the full length of the bottom. So I cross multiply here. I've got 6x plus 6 if I distribute, equals 16x minus 8. And again, I distributed both as I cross multiplied. All right, so I'm going to subtract the 6x over. That gives me a 6 equals 10x minus 8. And then we'll add the 8 over, so we get 14 equals 10x. All right, that means x equals 14 tenths, or 1.4. All right, so if I go in, all right, the x is 1.4. That would mean that this entire bottom here is going to be 1.4 plus 1, or 2.4. And then they asked me for EH, which is going to be half that. So we've got 1.2. So EH equals 1.2. And again, to me, that's going to be the quickest route through this one. There are some other options that we could take if we wanted to, but I think that's going to be the quickest route to go. All right, and then last but not least here, we've got the angle bisector theorem. All right, so this one is actually a little different. All right, because what it does is the angle bisectors are going to give this other ratio, and what I always think of is like over the top and through the bottom. All right, and that's going to be how we're going to kind of set up this ratio. It doesn't fit as well with the rest of the theorems in this section, but it is another important ratio that we get out of these, and it deals with how that angle bisector cuts the opposite side into pieces. All right, and it cuts it so that it's proportional to the other two sides. And what that means is if I look at this one, the AD here, which is on the bottom, AD compared to AC. So if I was writing this one, I would say AC over AD, right? So this piece over this piece equals CB over, so this piece over this piece, which is our DB. Now, as we notice here, it's clear that they've set this up in a little different way, and that's okay, because we've got to remember that we can always flip a diagonal, or we can flip over both sides of a proportion and it stays the same. So what they've done when they wrote this is they actually switched out this diagonal through here. All right, so they brought if we switch those out, notice we would be at AC over BC equals AD over DB. All right, so they compared this top piece up here to this top piece up here, and then this bottom piece to this bottom piece, which is totally okay. It's fine to think of it either way. To me, this way is the most effective because it visually is kind of what's happening in the triangle. I go up over the top, right, these two. That corresponds to the AC and CB. And then across the bottom corresponds to the AD and the DB. All right, but there are good reasons to set it up either way. Now, when I look at this, if we put it into words, it says, and blank in a triangle separates the opposite side into segments that have the same ratio as the other two sides. All right, so this is going to be the angle bisector. All right, and it separates it so that it has the same ratio as the other two sides. So that angle bisector, the way they're thinking of it is, again, let me clear this picture up, is they're looking at, for their setup, they thought of AD, this piece, over DB, that piece, all right, is going to be in the same ratio as this AC over this CB. All right, so again, these are equivalent. There's no difference between the two. It's just different ways of looking at it. Now, in practice, if we look at example 5, right, example 5 gives us a very quick setup for this. So if we go the direction I usually think of, I'll put an X here. So I'm going to do across the top, 60 equals X over, and then we have 40 and 30. All right, so if I cross multiply, I've got 60 times 30 equals 40 times X. Divide both sides by 40. All right, first thing I notice is that I've got, I can go ahead and reduce this down to a 4, and then this to a 6. All right, from there I can take a 2 out of this and move that 6 to a 3. And then I can put the 2 in there, and that's 15. 3 times 15 is 45. All right, so we get that missing side, CB, all right, CB is 45. And again, we're setting up this proportion from this new theorem that we have to work with. In example 6, it says in the figure below, triangle ABC, all right, is similar to GEF. So again, they're kind of a little bit of overlap in this one, but that's okay. They tell us AF is congruent to CF. So this piece here is congruent to this full piece here. All right, FG is congruent to GC. So they've told me this piece and this piece are congruent. And they've told me that DC is the same as those, so that's here. All right, so first thing I'm going to do is I'm going to get some of these sides that we don't have. All right, it's 80, so we've got 40 and 40. That 40 switches to a 20 and a 20, and then the congruence tells us that's a 20 as well. All right, it tells me to find EC. So what I'm going to use is I'm going to use the bottom of this one, which is 40, and the bottom of the big one, which is 80. So I have 80 over 40 equals, and then I'm going to compare, as we go through, I'm going to compare their medians. So equals 30 over X. And the X is the EC. So if I cross multiply, I have 80X equals 30 times 40. Divide by 80. 40 goes in there twice. 2 goes into 30, 15. And I get X equals 15. So the EC is 15. And again, notice that like I'm showing you the way I'm doing the mental math, but you're more than welcome to always use a calculator for that. All right, so I hope that helped with the second set of notes. And again, we're just getting a series of proportions that we can set up when we know two triangles are similar. All right, hope that helps. We'll be back with a review tomorrow. Have a good day.